The result I want to talk about today is that the class of transversal matroids of rank R can be characterized by finitely many excluded series minors. And if I can get through all the definitions and background in time, I hope to give a sketch of that proof. So I'll kick straight into it, I guess. So a transversal matroid is, as the name suggests, they're so called because they arise naturally from transversals or set systems, where I guess the independent sets of the matroid correspond to sets that are partial transversal of the set system. Now, I want to think about it in a slightly different way. So this definition, a matroid is transversal if and only if the elements can be placed on a simplex such that the cyclic flats correspond to facets of the simplex. We draw that something like this. So I guess everyone's favorite simplex is the triangle. And draw the elements on something like this. This will hopefully come in handy later. So for example, each facet, so the faces correspond to the cyclic flats. And you'll notice that means that there's a limit on the number of cyclic flats that we can have in a transversal matroid of rank R. It's 2 to the R. Yeah, so any matroid can have more than one such presentation like this, but they all have at least one. And that's one with a corresponding set system. Series minors. So a series minor is essentially, we limit ourselves to only series contractions. So we have deletions and not regular contractions, but we can contract a series pair, which is a co-parallel pair, so something that's parallel in the dual. Now, if like me, you find thinking about series contractions kind of painful, then you won't lose too much by just imagining we're only interested in deletions for today. And for bit of minors, I don't think I need to tell people too much about why that's interesting to matroid theorists. And of course, the big problem with transversal matroids, which is why we're talking about series minors, is that transversal matroids, they're not a minor closed class, so we can't even really start to think about a question. We can't define them in terms of excluded minors, so we're going to have to think about excluded series minors. I just want to show this nice little sketch of gamoids. It's a nice way of thinking about it. So you can see that we've got deletion going one way and contraction going the other way. So transversal are closed under deletion, but not under contraction. And of course, we can add in series contraction to that. Now, the general case. So I'm talking about fixed rank today. And the reason for that is that the general case is not characterizable in terms of finitely many excluded series minors. Now, I can't actually remember exactly where I first saw the example, but I think it's due to Buraldi. So if you take the matroids which arise from these graphs, these double cycle graphs, that actually forms an infinite anti-chain of non-transversal matroids under taking series minors. So that's the problem there. Okay, so the fixed rank case. So I think probably doing pretty well for time. So I'll try to run through this argument. And essentially, we bound the number of excluded series minors by bounding them in terms of size. And then obviously, that's going to bound the number of possible elements. So we've got this number that we're going to show they're less than. And there are two conditions that will be violated. One of these must be violated if we have a sufficiently large number of elements. And the first of those is that, obviously, if we've got an excluded series minor, it's minimally non-transversal, so any deletion is transversal. And so we have to meet that condition of having at most 2 to the R cyclic flats. The other condition, it's a little less obvious why this is true, but not exactly counterintuitive. So at most, R elements can be freely contained in any cyclic flat of our excluded series minor, because otherwise, we would be able to delete some element from that and it would still be non-transversal, so we wouldn't have minimality. So the argument roughly goes like this. I've put those two conditions at the bottom, so remember what we're looking for. So we consider some deletion, and I'll start drawing this here. So imagine we've got some excluded series minor, and it's got a very, very large number of elements. And we're going to show we run into a contradiction. So we take the deletion, deleting some element, and that's obviously still going to have a large number of elements. So, and then it's kind of a basic pigeonhole principle, I guess, we see that some facet of the simplex is going to have to contain a very large number of elements. So that's essentially going to be elements that are free in a cyclic flat of the matroid. Now, if we imagine going back up to M, so we've got this cyclic flat F here with a lot of elements in it, and if we think about that, you might think there's going to arise then another cyclic flat in M. It will still have a lot of free elements. So that's going to contradict condition 2. Now, there's one way that we can avoid that, which is that if, as we add back in E is then contained in lots of cyclic flats with various elements of these. That then, of course, creates a situation where we have many, many cyclic flats in M, and each of these elements can only be contained in so many of those cyclic flats with E. Otherwise, we contradict freeness back in M\E. And so we can then choose any one of these elements, and we delete that instead. So we take M, delete some other element, and we still have a large number of those cyclic flats remaining. So that's the argument. And just to finish with a nice picture, so this is all the excluded series minus transversal matroids of rank 3. And I think that's me. So thank you.
Any questions for Will?
Do you have a good idea about how many of these things there are? Certain ranks?
No, I mean the only, I think, useful bound we have is that bound, so on the size, and but yeah, on the actual number, nothing more useful than what you could just derive from that. I suspect actually relatively small, but